I'm excited to have Matthew to talk about TransmogrifAI. I'm not sure I pronounce it correctly, but you can correct me later. Open an end-to-end automated machine learning library for structured data that is used in production today to help power the Salesforce Einstein AI platform. This talk will highlight key capabilities of TransmogrifAI library and demonstrate them in action on a real-life machine learning applications. Matthew is a principal member of technical staff at Salesforce, which powers the world's smartest CRM, or in the Salesforce Einstein AI platform team. Before joining Salesforce, he acted as a director of engineering at Badgerville, implementing scalable and highly available real-time event processing service with Scala. Without further ado, let's welcome Matthew. Hi, Matthew. You can start whenever you are ready and take it away.
Hi, thanks for having me. Thanks for the introduction. Let's jump right into it. I'll just start by sharing my screen. Okay, let's see. Okay, can everyone see my screen?
Yes.
Okay, well, let me find where I am. Okay, so some of you might be familiar with Salesforce. Well, Salesforce is a cloud company, and we do a lot of stuff around data. We process customer data in the cloud and so forth. So Einstein is an initiative that we announced a couple years ago, and was built to bring artificial intelligence closer to customer data and provide insights and predictive capabilities on top of that. But my talk is not about Einstein. My talk is about the open source library that we've built during that process. So I hope this would be very useful for you, and then after the end of the talk, you can go and try the library out. Okay, let's start with this. I think it's important to start with a forward-looking statement. Let me summarize it for you very quickly. So what it essentially means is that not everything I say might be exactly correct. So don't base your product and company decisions solely based on my presentation, but apply other sources, consider other sources as well. So can I repeat what Salesforce is? Salesforce is a multi-cloud, multi-tenant platform. When I say multi-cloud, it means that we have a ton of different capabilities that Salesforce provides as a platform. We have APIs and systems for sales. We have the marketing cloud for the marketing campaigns. We have IoT cloud, commerce cloud, chatbots. So we have a ton of different APIs and services that we provide ad hoc and interconnect between them for different customers. And customers vary a lot. So for example, the needs for application development and predictive capabilities for American Red Cross would be way different from those that the US bank might have. While they might be similar, they are very different in terms of the data distribution and different types of questions that data scientists and engineers might ask. Same goes with, let's say, Comcast and maybe like L'Oreal Paris. So when we started building the Einstein platform, we started building case by case, and then we figured out that a lot of cases can be handled similarly because of the fact that the data that we have in Salesforce is all structured. So machine learning is really hard, and then some of you might already know that, and it's much more complex for the enterprise when you have a lot of restrictions. When you don't have full access to the data, it might be encrypted and might be situated in different silos. It might be partially or not partially structured. But we learned three very important major things. Is that customer-specific models usually beat global models, which means that if you train one, let's say text embedding on a very large corpus of data, it might perform way worse than an embedding that was trained precisely on the customer data. For example, let's say you have an oil industry and medicine industry that would have very different dependence. Second is the majority of business data is actually structured. We're lucky that our data is stored in a normalized form, majority of it, and databases. So it's not something as difficult as we have with, let's say, video streaming processing. And then there are too many use cases and too few data scientists across the world to actually fulfill the needs of the enterprises. So let me expand a little bit on those three. So as I mentioned, customer-specific models usually win over global models. But another two additional aspect is that our customers do care about privacy. They don't want their information or their prediction factors being shared across other different, other maybe competitors, competitive companies. And then essentially every customer data is different, and you would learn this very quickly once you start building machine learning as a platform capability, because not every time the model that you get performs well, or it might change depending on the business process that each customer has. The second point is that majority of business data is structured. So this is based on the Kaggle survey, but there is actually a more recent one which yielded similar results. We also had our own surveys that we did across customers, is that most of the data is still stored in relational data, and it's not really being tackled with the majority of the machine learning applications that you would see, or open source libraries that you would see out there. So we actually had this need to solve this. And the third is that there's really too many use cases and too few data scientists in the world to solve it. You can think of it as, okay, let's say you're a company, you might have a problem in which you would go through this vicious cycle of data preparation, feature engineering, feature selection, model training, producing a model. You might repeat that cycle multiple times until you're happy with your model. And each time you have a change in your training data set, training data, or a process, you would actually go and tune your machine learning pipeline a little bit to accommodate that. So imagine you would do that numerous times for each of the customers, and it becomes very quickly infeasible for any human team to actually do that. So the result is immediate and obvious. You want to automate those processes. So TransmogrifAI actually solves those three things. So it's oriented to solve build customer-specific models, build those models at scale, meaning not only independently on the data set size, but also a number of models that you want to build quickly. It's tuned for structured and transactional data. And what it basically provides is that you get data science at scale, automated data science. So on the right, you might see the snippet, how some of the code would look like. I will show later the demo on the actual application. What essential things that we achieved with TransmogrifAI is automation of feature engineering, feature selection, and model selection on top of structured data sets. We also double down on machine learning abstractions that actually improve developer productivity and reuse of the code across different project or code bases. And then another important factor is actually having good explainability and visibility for users from our models and predictions that we provide. But most important is probably the accuracy. So we're trying to achieve human-like accuracy, but with a huge reduction in time. So I don't know how, I guess you will see it in the demo, but for us, this was probably the killer feature from this library, is that we can get our models into production very, very quickly within hours, and not spending months of trying to tune them and spend our time on preparations. So what's in the name? So some of you might be familiar with the Calvin Hobbes comics, in which Calvin actually made up this TransmogrifAI box, which would transform different things in a magical manner. So This is how we thought about TransmogrifAI, as it's a magical library that knows to produce insights and models and predictions out of your data. For our platform, so this is like a eagle-eye view on Einstein platform as it is right now. There's obviously much more things than just TransmogrifAI. So TransmogrifAI focuses on the machine learning and automated machine learning part of it, but we also have deep learning and other services that actually support all those things for TransmogrifAI, all those scaling and compute for Spark and metrics collection, exploration, health monitoring, orchestration of your machine learning flows, and so forth. We do plan to open source some of those pieces, but not in the near future. Currently, TransmogrifAI is the only piece we open sourced. The applications we'll build on top of it, it's actually already shipped 4 applications, Einstein lead scoring, case classification, engagement scoring, and Einstein prediction builder. And we currently ship more than 4 billion predictions per day using TransmogrifAI library. Now, here's an example of the Einstein prediction builder. What kind of capabilities were built on top of TransmogrifAI, just to illustrate how simple and convenient the user interface eventually is. So what users do is that they select a table and they define training and scoring filter. Then they define the label they want to predict and go through this next wizard, and eventually they get a prediction back. So when we heard about this, from engineering perspective, it did sound impossible at the beginning, but once we started to unravel this, we were able to achieve this vision and ship this feature to Salesforce as a GA offering. So under the hood, TransmogrifAI does pretty much these 3 things. It does much more, but in this presentation, I'm only focusing on these 3. Is automated feature engineering, feature selection, model selection. So let's look on how we do automated feature engineering. So first of all, it starts from a type hierarchy. TransmogrifAI operates mainly based on data types, and for which we build this beautiful type hierarchy that we actually use for machine learning specific applications. One of such is TransmogrifAI. So for example, in the regular type hierarchy, if you'd open, let's say, Java language or Scala language, binary would not inherit from numeric, but from data science perspective, it makes a total sense. Treat binary as a numeric, and also it's a single response categorical variable. So using those types, we're able to encapsulate and hide a lot of complexity from users, and also give them a lot of freedom on how to define their operations for those types. So here's an example of how somebody would use it. Let's say your data set contains these 5 fields: email, phone, age, subject, and latitude, longitude, and some coordinate. So when you apply TransmogrifAI on it, it will verify if email is spammy or not. It will extract top K domains for the emails, and maybe for phone number, it will extract out the country code and create a categorical variable from it. It will check if the phone number is valid. It will auto-bucketize age based on the data set, based on the distribution in that data set. Let's say if it's a subject, a text field is being identified, then we'll extract out the top TF IDF terms and so forth. What eventually happens from this is that all those features being vectorized into some vector form based on the type, and then those vectors are concatenated together into large feature vector, which then used for feature selection and model selection down the road. So here's just some examples of what we do for Numeric. For example, for Numeric, we do automated imputation and null value tracking. So when the values are missing, we would impute based on the mean value on that column. But we also add a null indicator. For categorical features, for example, we currently do one hot encoding in which we encode categoricals into the max number of categories domain based on the data set. TF-IDF, I'm going to skip on that. That's a very common technique as well, where we extract top terms. But for example, for date features, we found it very useful, for example, to encode dates as circles and to do circular date transformation, which eventually make dates a categorical feature because they just fall into the coordinate system of a circle in which each date value is encoded into, let's say, a month or a day or an hour. And we obviously test all those approaches on a large number of data sets that we have internally for Salesforce. So here's some examples that things we support for different feature types. As I mentioned, imputation for numeric non-value tracking, obviously scaling, normalization, smart binning. For categorical, we'll do, as I mentioned, one hot encoding and dynamic hot pivot and so forth. For text, we have also a lot of information, approaches that we implemented. The things that the library was built the way that we made it very easy for users to add different transformers and estimators. And I hope this terminology is familiar with you to you, because it's been actually reused from what we had in SparkML and other popular libraries. So next step is automated feature selection. Which means that once you have the feature vector, we go and we're trying to filter out all those features that have poor predictive capabilities together with the label. And there are some specific problems that actually come with enterprise data. I actually mentioned 4 of them here, but there are more. One of them is Hindsight bias. The second one is field usage changes, bulk uploads is the third one, and then field type abuse. I'm going to just highlight what are the issues that are covered inside each one of them. So Hindsight bias, we also call it label leakage, is something that something as follows. Let's say you have one field in your relational database that's being updated just before your label value is populated. So in this case, we have a lead before it's converted to opportunity, and then the value of the lead is being updated with some number. So this value will be closely correlated with the value of the label. So you can think about it as as a Marty McFly turns to the future and gets his hands on the sport almanac and then goes back in the future and so forth. Start predicting the future events. So this is very similar, is that we want to eliminate all those features from a data set and from the model, so they won't be used to producing predictions. Second problem is that the field usage in the data set might change over time. So for example, during training time, we have this nice distribution of values and some categorical feature. But when we actually go and start scoring the values over the course of the year, for example, or over time, we actually see those values are no longer populated. And this happens usually due to some process change that the customer has. And unfortunately, again, we cannot see what customers do, really, so we have to operate in some sense blindly. That's why we use statistical approaches to eliminate and detect these features. The third problem is the bulk uploads, where some of the data is being not populated by humans, but just uploaded using some automated process. And then we have somewhat overpopulation of values in in this case, we're looking on the dates, right? Percentage of positive outcome on some date. And sometimes we just have more samples on some period of time or less, and it's not necessarily the correct signal. So we also need to identify it. The fourth problem is that we have incorrect usage of feature types. Let's say customer defines some features text, But what it really is, it's not a text. Inside the text value, they actually store some of the some information of the categorical form. And if we detect that it's a categorical feature, we actually can encode it better, produce better results for models. So we also implemented a lot of techniques to detect it. So yeah, it's gonna follow the same example. So all those problems that I mentioned, we were trying to tackle during our automated feature selection, which operate on top of feature vector plus the label. And then what we do, we analyze features based on their, first of all, simple statistics such as min, max, variance, number of nulls. We check that they have acceptable ranges of those features. What we also do is that we also compute correlations of the feature to each to the label based on the point-wise mutual information, Pierce correlation, and so forth. Depending on the feature type, we use different statistical approaches. So yeah, I think that's another illustrative slide to emphasize that we use different types of features, different types of approaches for different feature types. For example, Pearson correlation and Kramer's would be used for categorical features, auto-bucketize for numerical features, using the info gain. J7 divergence would be used for the rest of the features, and so forth. And on the right here, you can see the feature lineage. This is the number of transformations from an actual customer data set that we use, that we apply for each feature type. So if you would go and ask a data scientist to prepare a similar transformation DAG, it would be a very, very tedious job when we fully automated it. So here's an example, for example, for the first problem of the label leakage. Usually what we see is that when we train a model, it has a very good performance on the training set. It might actually have a very good performance on the holdout set as well. But when we actually apply it during when we start evaluating it on the actual data, the performance drops significantly. So when we apply our label leakage elimination techniques, what happens is that with TransmogrifAI models, you have sometimes a worse performance on the training and holdout data sets. That's due to the fact that we do remove a lot of features that we detect as leakers. But then during the evaluation, actual evaluation of the model, the quality jumps up significantly. And here's another example of label leakage. This is just like two sets of features that an intersection of features that were removed by the data science manually on the right, and then on the left, this is the ones that were automatically removed by TransmogrifAI. So what ideally we want to see those merge, but it definitely will never happen. So some combination of automation plus manual curation would actually provide even better results. But definitely AutoML is an excellent start. Okay, so I spoke about this already briefly. And the last section is automated model selection, in which we try to compare different algorithm approaches for each model, problem type. So for example, if it's a binary classification, we would try logistic regression and random forest and XGBoost and so forth. We'll run them and execute them in parallel and evaluate them based on the custom or default metric that we put in. And eventually it yields us the best model, algorithm approach to that particular training set. Apparently, it's very important to actually check all those different parameter sets and permutations of thresholds, because we put just like this short. Unfortunately, I could not put any information on Axis, but different customers actually have different models that perform better for their data sets. And you might find the same once you start using TransmogrifAI. So let's actually try and see the demo. I think I'll stop sharing this screen, and I'll have to start sharing. Another screen. Okay. So can everyone see the IntelliJ window? Okay, I hope so. Okay, good. So I'm going to show you kind of classical problem on Titanic survival. We have a data set from Kaggle that just shows a list of passengers on Titanic. It has several columns. One is an ID. Second one is actually if the person survived or not. I don't remember what the third column is. The fourth is a name. Then we have a gender, age. I think it's a port number or something like this, and so forth. So we have this data set. What we want to predict here is that we want to predict if a person survived the disaster or not, and we want to see which features contributed into that. So how do we code it with TransmogrifAI? So the simplest way of doing it is starts from a person. So this is again Scala code snippet. Might look familiar to whoever works in Scala. Whoever is not, I can explain some of the things. So for example, we would start by defining an object. This is going to be our application. And then we define a main function here. It's going to be executed. So we started by defining a project class, just a container to represent each row, each passenger, which has, as I mentioned, ID, survive, passenger class, name, sex, age, siblings, spouses. I think it's number of siblings and spouses, number of parents and children, ticket, fare, cabin, and then the port where it's embarked. So TransmogrifAI uses Apache Spark. So we start by pulling up a Spark session and then materializing the data set. So here we're using the simple CSV reader. So I'm using this factory for readers. Data reader is a simple CSV case reader, providing some simple key function, and materialize a data frame, Spark data frame out of the data set. Here's the TransmogrifAI magic in action, where we take, we automatically create features from a data frame in which we say, okay, response feature will be survived. So we get the pointer, basically a type-safe pointer to that feature in the data frame, and then all the other features, array of all other features. So what we do for features, we just basically apply this magical shortcut, which I will drill down in a moment. And it produces us a feature vector that combined large feature vector with all the features combined. Then we apply the Sandy check-in to do the automated feature selection, in which I say, okay, go check every single row in the data set, and yes, also go and remove the bad features if you detect them. After that, I create a binary classification model selector using cross-validation, in which I specify 2 model families and set the inputs in. At the end, I stitch it all into the workflow, in which I said, okay, this is your input data set of the data with the result features of prediction. A prediction is also a type-safe pointer to a prediction column that will be produced, and I hit the train. So once the workflow is trained, we receive a model, which we can get a lot of interesting information from, and of course save, load it, and use it for scoring as a bunch of interesting stuff in it. So like a summary JSON, summary really, you have the score methods, and so forth. And as I mentioned, like save method. And so I actually did execute it a few moments before. Let me share my other. So this is my terminal. So the command to execute it is basically Gradle Spark Submit. We have a handy script to do Spark Submit. If you're an SBT, there is a plugin to do that. If you just run in Spark locally, you can also combine an Uber jar and do it. So just a regular Spark submission. So I'm using local Spark here, in which I say, okay, run this Titanic mini demo with the CSV file. So what it runs, it's just bringing out the input path for Spark job. And here's the model summary that actually produces after a minute. It shows that it evaluated 2 model types as I requested, the logistic regression and random forest, using a cross-validation with area 100% recall metric. In total, it evaluated 26 models, and it shows also the average of the metric, and it shows actually the parameters of the selected model type for this data set. It also shows what were the parameters that were used, because it actually evaluates multiple regression models, so it shows the median one. What it also shows the different other metrics that were computed during the evaluation. For example, for the training set and holdout set, we see the performance of AUROC and AUPR for each of them. We also see the false and false negative, false positive metrics, and so forth. Another interesting tab that is being printed, top model insights, which actually shows what were the contributing factors for the survival and versa for the. So, for example, if the gender was female, the survival rate was high, and this is what we actually know from this data set as well. Also, the name is actually interesting, is mainly because name contains the prefix Mr. Mrs., so it also very closely correlates similarly to the gender, because of a similar indication, and so forth. And there's a negative correlation, of course, same thing, right? You have the males are negatively correlated with the survival, and so forth. These are the contributing factors. Again, and then there's a Kramer's V. This is a feature significance. Okay, so this is a very nice little start of what you can do. What you can also do with TransmogrifAI is you can start expanding this and customizing it as much as you want. So, for example, Titanic. Again, similar to Titanic, what you can do is you can also define your features one by one. So, for example, each feature can be defined in particular how exactly you want to extract it. And then you can also define in particular how you want to vectorize it. So I don't have to use the TransmogrifAI shortcut. For example, I can do, I can take name and add maybe, what else do I have here? Let's say I have, say like I want to define a feature called family size. So I will do siblings, spouses, plus parents, children, plus myself. And all these operators work exactly as you would expect them to work. Actually, I don't know why they don't highlight it. They're not highlighted right now. Siblings, spouses, large. Yeah, weird. Something is not working here. And then you can do custom feature engineering the way you would do them. Like, let's say you can do like tokens, and I can do name dot tokenize, and then when I tokenize, I can also check if I want to do language detection, and so forth. Under the hood, what it's doing, it applies a transformer or an estimator, which is very easy to extend. So, for example, if I drill down to the tokenize, I have this text tokenizer. So this is pretty much all you would need to write if you define your own custom transformer. So it's like a class tokenizer, extends unary transformer, and so forth. Okay, what else do I want to show? So yeah, you can customize significantly what you do with feature engineering. You don't have to use a TransmogrifAI. You can just use different approach, TF-IDF maybe, and then what this produces a vector, which you can then use as your features and so forth. You can also customize the way you do your model selection. You can customize the grid for each model, and we currently support probably for binary classification. We probably support, I don't know how many. Let me see. Yeah, we support like eight different model types. It's everything that Spark supports plus XGBoost. We'll keep adding it. And in general, we do support binary classification, multi-class, and regression models right now. We're planning to add more model types, and also for something that is not supervised. Okay, yeah, let me get back to the slides. I have a few more slides to finish. So how well does it work? So it actually works pretty damn well. We're very proud of this library. You know, it currently runs 4 large applications that we GA'd on Einstein platform. Most of our models that we deploy to production completely hands-free. We don't even look on the data. Customers drive model creation using wizards on UI, and then models get created, trained, and served without any human intervention. What do we do next? We're going to be investing more time and efforts into model and score insights, implementing Lime, we already implemented Loco, implementing higher and better search strategies for model selection, improving our feature engineering, because currently we use some of the simplified approaches for text. We're working extensively on model portability. Right now, our models are runnable either within Spark or in our local JVMs. We're also considering making them runnable using MLeap. Obviously, perf tuning and so forth. And yes, based on your requirements and feedbacks, if you have any feedback, definitely reach out to us. So what you can do next, you can go check out our blog post about why and how we open sourced it. It's actually a fascinating read. You can try it out by browsing to the website. Yes, contributions are always welcome. And then if you're feeling creative, we're actually looking for a logo. So yeah, send out your ideas and logos or just make us one. It would be awesome. So yeah, I'm open for questions. I don't know how we do questions here. Just probably on the chat.
Actually, we have a few questions in the chat window, and also, did you see in the QA section they have?
Oh yeah, I can see Q&A section.
Okay.
It doesn't open for some reason, but it's. Okay, yes, let me show something else. Okay, so the question is it open source? Yes, it's obviously open source. Let me show where it lives. So you would browse to TransmogrifAI. This is the website. And this is the library. It's open source since last August. You can find it on GitHub. It's deployed to Maven Central. It's fully usable. We've made 5 releases with it. You know, it currently supports Spark 2.3 and Scala 2.11. We have extensive documentation which you can browse, a ton of examples. And if you have also feedback on how we can improve it, also reach out. All the examples that I showed are there. So the question about does it work with Python? So it doesn't work. It does not work with Python. We actually plan to expose some of the interfaces for Python. Currently, what we've seen people doing is that they use PySpark to start their Python, to run their Spark jobs, and then they invoke Java classes or Scala classes from Python, and then use the same Spark session to get access to the results of TransmogrifAI. Yes, we are planning to add some bindings. It's actually, I think it's actually on our issues page. Maybe not. Yeah, we should add it. But we are planning to add some of the interfaces. But Python wasn't really ever our focus because we enjoy using typed languages. ID, so the question, which ID did I use? I used IntelliJ, and it has this material theme on it. So what backend can we run this on? So you can run this on Spark, and right now it only leverages classical Spark runtime. We currently run it on Amazon AMR for Salesforce. And people also use it in different notebooks. Yeah, we actually have a lot of examples on how can you use it in different notebooks. Go to Hello World. We have examples of several notebooks for the same problems. in general, all the documentation is available from the doc site. So there's the documentation here. We put a lot of effort in building documentation, so you can try it out in Jupyter notebooks. We have good instructions on how to set it up. It's very simple. So SparkML is being wrapped using this library. What we add on top, we add type hierarchy and we add type safety. Plus, we add a lot of other things that you don't have in Spark. So whoever is familiar with SparkML, so SparkML allows you to define your own custom transformations, stitch them into the pipeline. It becomes very difficult if you have hundreds of thousands of transformations, and this is what we automate. And also the model selection, yada, yada, things that actually not present in Spark at all. Because we originally, a couple of years ago, once we started this, we started from Spark, and then it grew to become this library. How to connect anonymous user activities to customer database. Not sure I follow. Okay, I don't know what to, maybe there will be clarification of that. Okay, question, can you shed some light on comparison with other AutoML products like Google AutoML, MLflow? Okay, so MLflow is not AutoML product. It's more of a workflow runtime and machine learning operational orchestration system. What we do end-to-end machine learning inside a single application, multiple application that you develop on Spark. A lot of automation around it. How do you build and serve it? But Google AutoML is a good comparison. I think there's a Google AutoML. I think it's like the whole table like this. This will be probably the closest. Yeah, here AutoML tables. This will be probably the closest comparison to what TransmogrifAI does. I don't know, where is it? Yeah, build and deploy state-of-the-art machine learning on structured data. So yeah, check it out. We actually compare our AutoML together with other libraries such as AutoKeras and there was another one. I don't remember which one. Feedtran, I think Feedtran. We stand pretty well good compared to those. H2O AutoML with sparkling water. Well, so H2O requires you to use their service. What we offer you is a library which has no strings attached. You can use it. You don't have to pay anyone. It's BSD3 license. So that's the main difference. Is it possible to use this library for large projects? Yes, it's very much possible. We're running it on data sets. Largest data sets that we have, they are more than 100 million rows. It works fine. You just need more machines. So make sure to tune your Spark cluster. We actually did spend a lot of effort into model training tuning. So in terms of the machine learning itself, there's not much you would need to do. What else can I tell about this? Okay, that's maybe another question. How does this differ? Okay, I think HTML also open source, only driverless. Okay, sure. Yeah, by all means, I'm looking forward actually if somebody can make a comparison, a good head-to-head comparison on how on some set of data sets from Kaggle, that would be good. We would love to have it inside our repo, let's have a comparison. Somebody asked to enlarge the font. Yeah, I could not see that, sorry. The entire last section was not visible. Oops. Yeah, sorry about that. I didn't see that message. In terms of presentations, okay, if you would like to get the slides, so we have the slide share. So it's on my slide share. You can find me on SlideShare. I have several presentations available in there.
Can you post the link to the chat window maybe?
Okay, yeah. So you can check out, maybe I'll just...
or you can send it to me later, I will share it.
Yeah, so slides. What else can I tell you? I think the best thing is just to try it out. You can go, of course, watch presentations. We have actually a talks section with all the talks that we've given over the years. So before it was even open sourced, and we did internal pilot with other companies. So right now it's all open source. You don't have any other excuse rather than not try it out. How much change in the code we need to use Databricks koalas to use Transmogrify if I come by Python background and use pandas heavily? Well, I cannot oversell or excel using Scala. So yeah, you'll have to learn a bit of a Scala, definitely. So yeah, it's going to be change, of course, yes. So, okay, any more? Okay, any more questions?
All right, I think that's it.
Okay, thank you very much.
Any questions? You can post it now, or later on maybe you can reach out to.
Well, thank you.
I think there are one follow-up questions. I come by Python background and use the pandas heavily. Do you plan to support koalas in the future? Did you? I think you already answered